welcome to a presentation, MedAssistAI, like a medicine. It's a medicinal chatbot developed using a fine-tuned large language model. So we'll go in depth on each and every detail a bit later. So first of all, I'll introduce with all of the teammates. So we have Akhilesh, Pratyush, Radhika, and Venkatesh, and myself, Aditya. So so we worked on this project for the entire semester, and now I will just walk you through all the application. So for the backend instance, we have a size of 70 GB, and we are using Ubuntu 20.04 LTS as the image. And then in the firewall, we have allowed HTTP and HTTPS traffic. And then for the machine type, we have selected a N1 standard 4 machine. So like a very pretty basic machine. And for the front end, we have created like exactly similar instance, but with a very less size for storage, because like we like did all the initial setup, installed Python, and installed transformers, dataset, torch, sentence piece, PEFT, accelerate, skitlearn, fast API, UVCon, and Pydantic. So these were the libraries that we set up. And also we created a structure for all the files here. So we have an app folder and a dataset directory, and then a models directory, and then a scripts directory, and then we have a readme file also and a requirements file also. So first of all, I would want to talk about our dataset that we are using today. So the dataset that we have like trained on, so that we have prepared, is like the Ruslan MV AI medical chatbot, which is like pulled from Hugging Face. So it looks something like this. Like so it has like a rows and like columns for patient and doctor dialogue. So here patient is saying something and the doctor is replying. So this is the data, only the patient and doctor columns here used in the data set. And here and there are total of like around 2,57,000 rows in the entire data set. So this model took a lot of time to train, like somewhere around 200 hours. So like even for a small data set for like 142 MB. So like for this, and then what we did was we pre-processed this information, and like we pre-processed this information. So the pre-processing steps included combining patient queries and doctor responses. So this is how we have combined them, like just simply like appended them in a string and taken and then what we did was we tokenized the dialogues using the FLAN-F tokenizer. So essentially this model uses a tokenizer, FLAN T5 tokenizer, which is a sequence to sequence model. So here we tokenized the dialogue using the FLAN-F tokenizer, and then we saved the tokenized data. And then we saved the tokenized data in a project dataset. Okay, so so this was the essential prepared dataset process. So this took like around 200 hours. And like moving on to that, like once now that we've started like talking about dataset, now we'll have to fine tune a pre-trained model on the dataset that we have acquired. So for that, what we have done is, so like first of all, before that, I would want to talk about a pre-trained model, FLAN T5. So it's a pre-trained model from Google, which is designed for sequence to sequence tasks, and like so it's a very basic text to text transfer transformer. Like it follows that architecture, and it excels in a wide range of natural language tasks, including text generation, translation, and question answering. So so like if I talk about the fine-tuning process here, so we fine-tuned the FLAN T5 model using our medical dataset. The Hugging Face trainer class was used to manage the training loops and loggings and evaluation. So essentially, like if I talk about the training configurations, we have a batch size of 4, epochs 3, and learning rate of 5 into 10 to the power minus 5. So like if I talk about like further training, so we used low rank adaptation like technique to optimize the fine tuning of the LLM by reducing. So what we did was we introduced low rank updates to the attention layers of the model. So instead of updating the entire set of model parameters, LoRa only updated a small set of learned row rank metrics, which greatly reduced the memory usage and sped up the training. So what we did here was we set up the LoRa configuration. So R is the rank of decomposition, which controls the dimensionality of the low rank updates. Setting it to 8 means that the attention weights are factored into 2 matrices of rank 8. So, and like won't go like into very deep here, but like if I go talk about LoRa alpha, so like 32 here is the scaling factor used for learned updates, and then LoRa dropout, it is a metric that prevents overfitting by reducing a dropout, by introducing a dropout, sorry. And then we have target modules, like it specifies which modules, in this case queries, attention and value matrices, are modified with LoRa. And then bias indicates whether bias terms are updated, like we have set it to none because there are no biases here. So like this process again took so this process took like around 200 hours, and then we saved the model to our path in the models directory. So here is our model. And then so now if I talk about the other part of the like the main part of the backend information, so that is like we have used like the chain of thought and few shot learning methodologies here to improve the generation of our LLM model. So talking about chain of thought very quickly, so it's like a prompting technique which is used to guide the model to think through a problem step by step. So essentially for medical diagnosis here, like the chain of thought helped us by leading the model to break down the complex symptoms and medical problems, causes and treatments in a very logical sense, improving the response quality. So and like another example here, like for few short examples, is we like literally are like giving the model with a few examples of input output pairs to help it generalize better when responding to newer queries which it is not familiar with. We have included like several examples of like the medical examples to guide the model's response. So here are a few. So is bifunctional protein deficiency inherited? So it is giving a model response to the LLM and how it should respond to these types of queries. And then what we have done is we have exposed a API using fast API and like a post API called like with the endpoint predict. And here we have added first the chain of thought prompting, then we have added the few short examples, and then we have tokenized the input. And then like obviously using the model we are generating the output, and then like obviously we're just showing the response here in the API, and we are hosting it on UVCon library. So yeah, so that is how the deployment is going on. So like simply going over this. Okay.
Yeah. So for the UI interface of this chatbot MedAssistAI, it basically takes user input, sends it to the backend API, and it receives the response, and then it updates the conversation in real time. So the interface that we have built is based on Gradio, using custom CSS for styling, and it allows the users to interact with the bot in a chat window, and the chat window itself is then again styled by CSS. So the backend API handles the core logic for generating the responses. Now, if you look at the code, so we have at the top we have used two main libraries, that is Gradio and Request. So Gradio is it's basically a Python library that is used to build machine learning demos and UIs. Whereas the request is used to make HTTP requests, such as sending data and retrieving data from the backend API. So now coming on to this function, generate response, it basically takes up two parameters, and that parameters are user input as well as the conversation history. So the user input, it represents the text input that the user enters into the chat interface, and it contains the user message that will be sent to the backend API, which in response will generate a response. So the user input is then further included in a payload dictionary, right? As you can see, it is the input text in user input. So this payload is then sent as a post request to the API. And then later it is appended to the conversation history along with the assistant's reply. So this allows the chatbot to display both the responses from the chatbot as well as the inputs that are being provided by the user. So the other parameter, that is the conversation history, this parameters keep track of the entire conversation that is happening between the assistant, and contains the user input and the assistant's response. So initially, this list is empty, and it grows as the exchange happens between the chatbot and the user. So after the assistant generates a response, the function appends the user message and the assistant's reply to the conversation history list. Now moving forward, the styling for the interface is done using CSS and Gradio blocks. Okay, so so this code with the gr.blocks, this contains basically the body and the styling for the chat window, the submit buttons, the input box, and the background images. Right. So the interface uses a background image, and that image, the URL for that image is passed as a parameter, as you can see. Apart from that, we have also used a markdown, and that markdown is used for a header. So at the top of the output window, you'll see the MedAssistAI heading, whereas subheading that describes the virtual medical assistant. So that is being done by using the this markdown. And coming on to the script. So if you move down, yeah. So rest all is pretty much the styling, and in the end, when you hit the submit button, that triggers the response generation, and this send button dot click function that we have used, it links the send button with the generate API, generate response function. Input is the user message, whereas the text input and the conversation history output is the updates from that backend API that we are getting in response. Yeah, so that is pretty much the front end for this chatbot.
Yeah. So now, like talking about how we've connected both of them. So I have exposed the API in the. So we have exposed the API in the backend process, and like here is the API. This is the IP address for the instance, and we are using that API here to like generate responses in the Gradio script. And like right now, like now I'll just like quickly demo like 2-3 examples of the chatbot. So here I'll write, hi, I have fever, help me with some advice. Yeah, so like the instance is very like so the response is very quick. Like it instantly gave us like a few could of viral infection could be flu. Please stay hydrated. Monitor your temperature. If it persists, consider consulting a healthcare provider. We also have like a guardrail here for us. I have an emergency. Please help out. Yeah, so here if you're experiencing a medical emergency, please seek immediate help from the healthcare provider or nearest emergency room. Since it cannot like help out, or like since it's a bot, so it is technically not allowed to give out advices in form of instructions. And like if I have to answer, like ask it another complex query, then that would be for example, what is Tourette's syndrome? Let's try asking this. Yeah, so yeah, it always starts with this. Hi, I am MedAssistAI. Tourette's syndrome is a very complex disorder. So yeah, here is the demo for our product.